My name's John Price. I'm part of the Next Generation User Group. And we've all been to these conferences, and they're really, really great, and we learn an awful lot. But there's only so many presentations that you can just sit and listen to. The Next Generation User Group, when we do our presentations, we try to come up with a way of describing these new technologies or demonstrating these new technologies in a way that's a little bit more interactive with the audience. You may have seen us do various different game shows. We've done it half a dozen times both at TechEd and in the UK, and again here at Remix. And I thought we'd have a little look at just how we went about and why we built Swaggly Fortunes, which is one of our most popular game shows. Okay, so I don't know if anybody's actually seen the show. If you have, we have a set of questions, and we have two teams, and they take part in the two teams, and then they take turns answering questions. Okay, the main screen is in two parts. It's quite difficult to demonstrate those two parts on a laptop, but if you can imagine our black main screen here is the bit that appears on the big projection screen, so the audience see that.
Name a make of computer monitor.
And this little control panel here is the bit that I would see to operate the game show from. You may have just heard Microsoft Anna, and we use the speech synthesis as part of the Microsoft technologies to be able to read the questions out. So we got a little piece of technology in there, and we can talk about how that actually works, but it means we've got speech synthesis involved. The whole of the application itself is a WPF application. So we've used this to demonstrate the way WPF works, and that we can use the interaction between a Windows form, which our main front form is, and the WPF application. So we can see the technology, we can demonstrate the two parts of the technology working together. Just very quickly to give you an idea how the game works, we have a question here that says name and make of computer monitor, and we have some hardware built, two big red buttons that the two teams take in turns in pressing, and this uses the DirectX technologies, and we have a human device interface in the back, it plugs into the USB port, and we built some specialist hardware, and we use these, the two teams press the button, so we've got DirectX involved. So if I just go and press the button just so you can see what happens, yeah, we got a horn and a little blue bar appears on the right side team. And then we've got an option to lock the buttons out so they don't keep pressing the button. And then the team would have a go at answering the question, so the answer rather. So name, make a computer monitor, somebody might say Dell. So we click on Dell, and they'd earn a number of points. Okay, and we keep playing that, somebody gets it wrong. We get the lose life sound, yeah, and they get 3 lives to answer the questions. And we play this game and we run it, say, on large events, but we also use this as part of the iLifter Code experience, and you'll find the whole of Swaggly Fortunes is actually written up on the iLifter Code site, showing all the technologies and how it's built and all the individual bits that make it up, and there's some code examples there and some of the detail on how we actually went to build it. One of the other things that we've done, myself, I'm a pilot and I fly with Coventry Aeroplane Club, and one of the other technologies we played with is when people come and book flights for birthday presents, so somebody goes out and they go for a flight and come back, how do we make that a little bit more than just them turn up and they disappear for an hour and then come back and drive away again? So we've looked at GPS tracking. So we have a little piece of hardware that lives on board the aircraft that tracks the movement every minute, and we just grab the GPS coordinates of where that aircraft is. When the aircraft returns, while they're being debriefed, we take the GPS unit and we download the flight. And then what we do is we save that flight, and we use Microsoft Flight Simulator to effectively recreate that flight. So we input the data, and we give them a video of the Microsoft Flight Simulator running that flight. And then we use some stock video of that particular aircraft that they've used, and we put that at the beginning, and some other stock videos that we've taken out of the window of the aircraft on where we know it was going to go anyway. And we brought that together, and they get a presentation disc of the whole flight and the whole experience, so they can almost recreate their exact flight. We can even record weather conditions and things like that we've done on it. One of the things we're looking to do in the future is to use some of the Microsoft Surface technologies. Listening to Bill Buxton talk this morning about taking the Microsoft Surface and involving real-world objects. So one of the things we're going to try and do is to take model aircraft and use those and place them on the surface, and then use it to plan routes and other details that we need to do in between. At the moment, to go and plan a flight, for every hour of flight, we're going to do an hour sort of planning. We have to go to lots and lots of different sources at the moment. So for example, to get weather, we have to go to the Met Office site. We have to go to the NIS site for things called NOTAMs, that tells us whether the airport's closed. We have to go to a different site to publish flight plans, and if we're going abroad, we have to notify the police on yet a different website. And what we'd like to do is be able to join all these things together. The pilot still needs to retain the responsibility for all this detail, but we can prepare the data, show it to the pilot, have them confirm all of the documents. We could produce the documents as they would look like on paper on the Microsoft Surface, and have the pilot effectively sign that electronic document and then transmit it to all those different sources and pull back together one single joined up picture of all that information that we need.